Okay, so today, I'm too loud, I can see it, I can hear it. Today we plan to go over few more indeterminate forms. What we have covered so far was 0 over 0, infinity over infinity. And if you remember everything from the beginning of the term, in most of the cases, we know more than one way to deal with infinity over infinity. But on Friday, we learned about L'Hopital rule. L'Hopital rules is a strong rule that now not only helps us to resolve this 0 over 0 and infinity over infinity, but also will help us to deal with more complicated indeterminate forms. So if I want to put a title for today's class, it would be Indeterminate Forms. Well, we already covered the quotient indeterminate forms. By that we mean when you have limit of two functions, f over g, and you either get 0 over 0, in other words, limit of the numerator and limit of the denominator is either 0 over 0 or infinity over infinity. So these are the indeterminate forms that we have been working with. And what we learned specifically to resolve these ones, if your functions are nice enough, which in our case, in our course, they will be, then we can use L'Hopital rules, which in quick review says, okay, now you can replace the numerator by its derivative, the denominator by its derivative. And then we have the discussion of how this is going to do the thing that we did earlier in the term, factor it, cancel it. There was some signs, some hints of why replacing f and g by f prime and g prime kind of does automatically, in a fancy way, factor and cancel. But then I want to introduce more indeterminate forms and how you want to deal with these ones. Before we go ahead and start listing and one by one we go through these ones, I want you to talk to your friend, to discuss with your friend what makes 0 over 0 or infinity over infinity something that we call them indeterminate. Why on earth, why don't we deal with these cases like as we did if it is 1 over 2? The limit of 1 over 2 is 1 over 2, yes? Why infinity over infinity or 0 over 0 should be considered special as an indeterminate form? 30 seconds. Be open with ideas. Don't try to remember something from past. Be upright with your friend. Try to see honestly why 0 over 0 and infinity over infinity has basically no information for us. That's why we call it indeterminate. You have to do something to be able to understand. Go ahead, 30 seconds, and I'll ask for 1 or 2 reports on that. Thank you. He wants to join you as well. 10 more seconds, 10 more seconds. Okay, can I get some volunteer to tell us why you think those things should be called indeterminate forms? Yes, please. Loud.
Okay. My best guess would be that indeterminate form basically means that the form that the answer will give when we evaluate a limit in indeterminate form is the indeterminate form basically means that you don't have enough information to derive an actual definite limit. That's what it's.
Thank you. So that addresses the thing that we don't say it is the value of the limit. It's a form that we have to deal with. But why? Why limit of something over another thing when both of them vanishing to zero has indeterminacy? Why, when two things growing to infinity or negative infinity, when you want to find the quotient, you cannot right away say, oh, this means it's 1. Like, why we don't divide this with that and say it is 1? Well, sorry, that's a bad question. I should not ask that question, never, because you're not allowed to do that. But that's the starting point of indeterminacy. Do I have any other guess, any other suggestion there? Why when I get to infinity or infinity, we say, oh, this is indeterminate. I don't know. I have to do something. Yes?
Because of the ratio of the top and the bottom, instead of a super small number, it's kind of like the number of scale up to the point.
Okay.
So that the form hides what the upper levels are.
In other words, I like the explanation. I'm trying to elaborate a little bit on that. In other words, when you see infinity or infinity, the only thing you know is that this is growing big, the other one is growing big. Like Elon Musk's money is growing big and big. Who else? Bill Gates' money is also growing, yes? When you try to find the ratio, you cannot right away say that, oh, this is growing faster than that or smaller than that. There is a detail there. Growing big is not enough to say what's the ratio. For example, if I have half of the money of Bill Gates, or no, why not Elon Musk, yes? If I have half of his money and my money grows as his money grows halfway, then the ratio would be half. And that infinity or infinity wouldn't say that. It could be twice as his money. And then in that case, I would say, okay, my infinity over his infinity is 2. So you already see that the infinity is just telling you something that cannot be used to find the ratio. And the same story will happen with the other indeterminate forms. The first one I want to start with, it's called product. Indeterminate. And when it comes to the product, we have one case that, first of all, we are trying to find the limit of f times g. They're multiplied. And one has limit that goes bigger and bigger, limit, infinite limit. The other one has a limit that goes smaller and smaller. One is vanishing, the other one is growing. So we have 0 times infinity. 0 times infinity is another thing. I don't know how fast this is growing compared to how fast the other one is vanishing. So when you're multiplying, you cannot right away say, oh, this is 0. This could be 10. This could be infinity. That's why you have to do some more work. One big advice to take home. Only 0 over 0 we are allowed to use Labtube. Every other every other indeterminate form that we are going to cover today, we have to do the middle step that transfers that indeterminate form to the quotient indeterminate form, and then we will be able to use L'Hopital. How do we do that? Simple. There are two ways actually. One, G goes to infinity. What was that? G goes again. Okay, I won't say G. G goes to infinity. Any number I give you, you can write it as 1 over that number. Inverse of inverse is that number. Now I can turn Gx to 1 over x. In other words, I can write f times g as f over 1 over g. Yes? Just simple algebra should show you that this is the same thing as f times g. But doing that, look what does this does. F, limit of numerator is 0. Limit of the denominator, gx goes to infinity. 1 over gx will go to 0. I turn 0 times infinity indeterminate form to 0 over 0 indeterminate. And I have the tool there. I can use L'Hopital. Or you could do the other one. You could say, okay, I am writing fx as 1 over fx. Instead of writing g as 1 over gx, you're writing f as 1 over fx. And in that case, you have infinity up there. 1 over 0 in limit is infinity. So you get back to infinity over infinity. And yes, you can use L'Hopital. Either trick you do, you're turning product indeterminate form to quotient indeterminate form. Why? Because I have a strong tool called L'Hopital's rule waiting for me to resolve 0 over 0 or infinity over infinity. And that's why I will try to repeat this process all the time. Turn all the indeterminate forms to 0 over 0 or infinity over infinity. Either 0 over 0 or infinity over infinity. And then there are other technicalities that function you have to be able to differentiate it in some ways. Yes, that's true. Any other questions? Any other comments? Let's do this then. Limit of x ln x as x goes to what? To 0 from the right. Also, I have limit of x sine of a number a over x as x goes to plus infinity. How about I give you 40 seconds for what? First, you have to make this habit of when someone gives you a limit, you have to do a first step evaluation of what is the situation. Are you going to use the quotient? Are you getting 0 over 0? Are you getting 0 times infinity? And you have to be able to do it because when it comes to the tests and exams, no one will say that do the following 0 over 0 indeterminate forms. You have to identify that. So you get in 45 seconds to identify clearly what is happening there. Is it 0 over 0, infinity over infinity, 0 times infinity, and if it is 0 times infinity, which is, but you have to identify that, then go either that way, and stop there. I don't want you to continue there. 45 seconds, go ahead please. That should be enough in identifying why these are indeterminate forms and announcing what kind of indeterminate forms they are. Ln x, when x goes to 0 from the right, ln x goes to the negative infinity. So we have 0 times negative infinity. In these indeterminate forms, these two and the sum of the ones that we will have, it really doesn't matter if it's plus infinity, minus infinity. Just so you have that one. I can now choose to either go this direction or that direction. So I can turn this either to, should I do this one? Okay, limit of, I can write x as 1 over x. Sorry, 1 over 1 over x. Or I can do it this is or. I don't want you to do both of them. You just need to know one of them. The reason I'm going with this one is that to let you know that sometimes it's not really easy right away to figure out which one you want to do. Sorry, maybe I should have done this part. This is infinity over infinity now, with minus plus. This guy is 0 over 0. Both of them you're allowed to use loop. And I think in my notes I decided to go with this one because I tried to do Labtube with this one several times, and then I noticed, oh, something is not working properly. You should be able to make it to work, but sometimes one case could be easier than the other one. So if you started with one case and you notice, oh, things are getting worse and worse, maybe stop, come back, start with the other one. So I will go with the first one, limit of ln x over 1 over x, as x goes to 0 from the right. We know this is infinity over infinity. I'm announcing what it is. I'm announcing what tool I'm using. L'Hopital rule, meaning that I can replace the ln x, the numerator, by its derivative 1 over x. And derivative of 1 over x is, derivative of 1 over x is, what? I need to go back to my office and change your grade for test 1? Negative 1 over x squared. Yeah? And when you look at it, if you don't do anything with it, any simplification, you are in trouble of, again, infinity over infinity. But if you do simplification, then you are in good shape. You can now just cancel this with that. This is basically direct substitution for limit of minus x. X goes to 0 plus, which is 0. Other one, x goes to plus infinity. This is infinity. 1a could be, I should have said this before. Any number but 0. A over x, as x goes to plus infinity, is going to be 0. So this is sine of 0. And sine of 0 is 0. So I'm dealing with here infinity times 0. 1 factor. growing big and big, the other factor vanishing to 0. Yeah? Now I can use either one of these tricks I have there. I don't like 1 over sine x. I will go keep sine the same way, replace x by 1 over 1 over x. And, well, now you see that this is 0 over 0. These steps are important. You're reporting your grader, the person who's reading your solution. At each step, what is happening? My new limit is now not product indeterminate form. It is quotient indeterminate form. So I'm allowed to use L'Hopital. And for the L'Hopital, I have to replace the denominator by its derivative. And the numerator, derivative of sine u is u prime, which in this case will be a over x squared minus a over x squared, cosine of a over x. Yeah? If you just go ahead and without checking things carefully, you can see this is again 0 over 0. But keep it in mind, any time finding limit, doesn't matter whatever indeterminate forms, if you can simplify something, simplify it. It will help you. Even with the tool like L'Hopital, it will help you to deal with simpler limits. So this is nothing but a cosine of a over x as x goes to plus infinity, and continuity of cosine tells me this is a over cosine of 0, which is any questions, any comments? So product rule, easy. You just turn it to 0 over 0, infinity over infinity, if the well, you turn it that way and then use L'Hopital. Yes? Now comes the next indeterminate form. Before I move to the next indeterminate form, is there any questions, any comments? Everything good? Yeah? Practice obviously needed, but let's go with this one. Now, the quotient is gone, the product indeterminate form is gone. Now we have difference. Indeterminate. And when it comes to the difference, you don't have any issue if you're trying to subtract a number from infinity, infinity from a number, two numbers. Those are all straightforward. But when it comes to infinity over infinity, plus infinity minus infinity. If Elon Musk decides to give me $3 billion, he is still billionaire, yes? So taking away a number that is growing big and big from a number that is growing big and big, or expression that grows big and big, you cannot say right away what will happen at the end. Is he giving all his money to me, or just a small portion of that, yes? And that's why this is indeterminate form. How do we deal with this? The general strategy to deal with this could go a bit complicated. I'll write it down, but I will try to show you step by step what will happen. But again, the idea is turn it to one of the cases that you know. And in this case, I can factor out either one of these guys. okay? And once you get into that case, there are two possibilities. What are the possibilities? If this guy, gx over fx, which by the way, it is now infinity over infinity, because g had limit infinity, f had limit infinity, so this is infinity over infinity. So you go ahead first thing, do limit of gx over fx as x goes to a, and you see that this is infinity over infinity, and then you can use loop. That's the first step you have to do. But there are two possibilities here will come up. Either it is 1 or not. If it is not 1, so I have something which is not 1 here, 1 minus that, it's a non-zero number times infinity, then you will get infinity value. Either plus or minus, you have to be careful there which one will happen. But what I'm trying to say here is that if it is 1, then you get 1 minus 1, which is 0, and you have infinity times 0. So then you're dealing with 0 times infinity, or sorry, the other way, it doesn't matter, infinity times 0, and then you have to repeat the process that you had before. But in either case, you should start with this guy here. That's the starting point for you, telling you that, okay, do this. If it is 1, then you're going to get into the trouble of infinity times 0, which you know how to resolve. If it is not 1, then you have everything set up correctly and you can run. Okay? There is also sometimes this f and g will be quotients themselves. They will have quotient structure, like it will be 1 over something, or fraction or quotient of two functions. Then in that case, maybe start with, you can start with finding common denominator. This sometimes will work, as though sometimes it will give you right away a quotient indeterminate form. You will either get infinity over infinity or 0 over 0, and then you can go from there. My suggestion is, if you can do the common denominator thing, put both of them in one fraction or one quotient. That would be the first thing you should do. If you can get it to infinity over infinity or 0 over 0, done. You just do L'Hopital until you solve. But in general cases, I'll try to solve one case for each one. This is what it will work. So that's how you can turn the limit, your indeterminate form into another form. Let's see this in practice. And if you have any questions, you can ask me why. I'll write this example here. Limit of 1 over ln x minus 1 over x minus 1 as x approaches to 1 plus. And I have another one. I'll keep this one for my last indeterminate forms. I'll write it here. Limit of e to the power x minus 1 as x goes to plus infinity. I give you 30 or 45 seconds. That step, you have to develop the habit. Someone gives you a limit. You have to understand where you are. When you're using quotient law, are you getting into an indeterminate form? If you are in an indeterminate form, what is the indeterminate form? Announce it. And then just start with one step. Just this or whatever is there. Do that step and leave it for now. 45 seconds should be good for both of these examples. Go ahead, please. Ln of 1 is 0. When you're approaching to 1 from positive side, it's going to give you, so as x approaches to 1 from the positive side, ln x will approach to 0 from using the positive numbers from the right hand side. And that means that the first one is 1 over 0, or a number that gets smaller and smaller, only using positive numbers, that's plus infinity. The same argument works with this one. In this indeterminate form, it's very important to understand both of those functions are giving you positive infinity. Because if it was plus infinity plus infinity, that's not an indeterminate form. You're adding big money to another big money, yes? It's bigger money. It's plus infinity. But only if it is, you try and take away infinity from infinity case is the important one. In this case, I will use this small trick. Even though it's not general, even though it's not working for all the cases, but in these cases, usually that trick is more useful than the other one. And what will happen is here, x minus 1 ln x, and I get x minus 1 minus ln x, as x goes to 1. And this is this 0 over 0? Yeah, it is 0 over 0. And I'm allowed to use log. Yeah? I should have written here 0 over 0 log. And log says that numerator can be replaced by 1 minus 1 over x. Denominator can be replaced by ln x plus x minus 1 over x as x goes to 1 plus. Yeah, it's again 0 over 0. It's again 0 over 0, but let me simplify. If you can simplify things, it's always useful before you start applying the tricks and rules you know. So here I can find the common denominator x minus 1, x ln x plus x plus 1. And then cancel out 1 over x's from the numerator and 1 over x from the denominator. And x goes to 1 in this case as well. So now, I'm again in the case 0 over 0, and again I can use Labtube, and this will give me 1 over 1 times ln x plus derivative of ln x, which is 1 over x times x is x over x. Derivative of x plus 1 is 1. So this is 1 over ln of 1 plus 1 plus 2. So this is just quotient law and direct substitution, which gives me 1 ln of 1 plus 1 plus 1, which is 1 over 2. So 1 over x goes, 1 over ln x goes to infinity. 1 over x minus 1 goes to infinity as x approaches to one from the right, but the difference in long run, as x goes to 1, sorry, as x goes to 1, gets to this number. So their difference is about half in limit. This guy, again, seeing that x goes to infinity, this is plus infinity, this is plus infinity, I have infinity minus infinity. I announce it, bless you. I see that, okay, this is an indeterminate form. I announce what type of indeterminate form it is. I cannot use L'Hopital until I turn it into 0 over 0 or infinity over infinity. This is something that I warn you now, that I see this a lot, that students, whenever they see one indeterminate form, they right away write L'Hopital. No, L'Hopital only works for the quotient indeterminate forms. 0 over 0, infinity over infinity. Unless you turn this into infinity over infinity, 0 over 0, you're not allowed to say L'Hopital. That's not going to pay your expenses there. Or you will lose marks. That's the other way to say that. So, what I will do here, I don't have any quotient structure here. I cannot find a common denominator, but I can use this trick that factor out one of these guys, either that or this. X goes to plus infinity. When I do that, I notice that, yes, well, things are complicated here, but what I know is that I have to take this part and see what is the limit of that part. So limit of ln x over e to the power x as x goes to plus infinity. This is another indeterminate form, but it's a good one. The one that I can use my L'Hopital cache to solve it, to resolve it. So I go L'Hopital and replace ln x by its derivative, 1 over x, e to the power x by its derivative, which is again e to the power x. Simplify before you proceed. This is limit of 1 over x e to the power x as x goes to plus. Now, this is growing bigger and bigger, e to the power x growing bigger and bigger, multiplied, you have infinity in the denominator. In other words, your denominator is growing big and big. Your numerator is fixed 1. That makes the whole limit 0. That's not the answer of the limit we were looking for. I just took this part and evaluated that part there. So now I have to bring it back, and I say that, look, this is infinity, 1 minus 0, so it's infinity times a number around 1. That would give me the reason that we are using indeterminate, you can see it on the board. Whenever I get to one of these forms, there is no unique answer for it. Depending on different things, look, infinity minus infinity gave me half. 0 times negative infinity gave me 0. I had another example which was a, something like that. Here I got infinity. That's why we call it indeterminate. Depending on case, you may get different things. There is no fixed value, fixed result that I can say, okay, whenever you get infinity minus infinity, it is half. No, it's not going to happen. Any questions, any comments? Okay, then that means that I can cover the last one. this is called another group of indeterminate forms. It's called power. Indeterminate forms. This will happen when you have two functions, one to the power other one. We have things like that. But if I have a number to the power another number, 1 to the power 2, 10 to the power 3, I'm good with it, that I can evaluate that. But if I have these three cases, I have to deal with them differently. What are these three cases? 0 to the power 0. If I want to be more precise, which would be not very proper to do it here, just there's a technicalities there. But in general, 0 is 0. If I want to be more precise, it must be 0 plus to the power 0. The other one is when you have infinity to the power 0. And the third one is when you have 1 to the power infinity. I was telling my other class, I don't remember at what stage of my education I came to the conclusion that, oh, these are why we have indeterminate forms. But one of the things that helped me to understand it is this, that, again, this is not the whole argument behind it, but just a hint of what's happening here. If I have any number but 0 to the power 0, what would be the answer? 1. If I have 0 to the power any other number than 0, 0 to the power 10, which one of those rules you want to use? Are you going to say it is 1 or it is 0? Again, this is not showing all the aspects of the story, but a simple way of seeing that, oh, even my oldest stories anymore is not working anymore. I don't know, should I apply every number to the power 0 is equal to 1, or should I apply 0 to the power every number should be 0? So that is, for this thing is the same story. If you have a number, non-zero number to the power 0, it must be 1. On the other hand, if you have infinity to the power any other number, you get either infinity or 0. So there are three possibilities there that you don't know what to say. That is just a sign that this is an indeterminate form. And the same story goes down there. I don't want to focus more on that. It's just an intuition behind. Like even my old rules, power rules, is not helping me to understand it. And that's one way to see that it is indeterminate. What are we going to do with these ones? There's one trick, nice, simple, and it will solve everything for us. It comes from this fact. We already used this fact somewhere. That if you have a to the power b, you can write it as e to the power ln of a to the power b. Yes? And then that is the same thing as e to the power b ln of a. So a to the power b, I can write it as e to the power b times ln a. And if limit exists, I can say that I'm dealing with b was the power gx times ln of. If everything works out well, so if that limit is in a number or something that I can evaluate, I can turn it to that form. Now, for example, this guy means f was 0, g was 0. Now look at this, g is 0, limit of f of x as x goes to 0 plus is infinity. So you turn this to 0 times infinity. Sorry, I should have done that the other way around. I should now say for each one what happens. This one will be 0 times infinity. This one, f is infinity, so ln of plus infinity is infinity. 0 is there, so this is also 0 times infinity. The difference is that this is going to negative infinity, this is going to plus infinity. Here, f is 1, so ln of 1 is 0. This is infinity times 0. What I'm trying to say is this. With that simple trick, a to the power b is e to the power b ln a. You turning your power indeterminate forms to product indeterminate forms. 0 times infinity or infinity times 0. And then you know how to deal with it. Turn either the first one to 1 over 1 over, or the second one. So you will turn it to 0 over 0 or infinity over infinity. I don't think I have much time left, but I'll write at least one example. If I have more time, I'll do another. So these kind of recipes just helps you to get an understanding of what's going on and how you should deal with this different cases. Limit of 1 plus 2 over x to the power 5x as x goes to plus infinity. I'll write one more if we have time, but I don't think I will get that chance to do that. Okay, here. 1 plus 2 over x is getting big and big, so this is 0, this is 1. So I have 1 to the power infinity. The method to resolve that inequality, that indeterminate form, for all power indeterminate forms are the same. So you're trying to find e to the power limit of, if the limit is good, 5x comes here. This is 1 plus 2 over x. Oh, sorry. No, what's the topic? No. Okay, sorry. Limit of, that's right, limit of 5x ln of a to the power b is e to the power b ln a. And now I take this limit and I want to deal with it separately. Limit of 5x ln of 1 plus 2 over x as x goes to plus infinity. This is going to be infinity. This is going to be ln of 1. So we are dealing with infinity times 0. Then I have to turn it to 0 over 0 or infinity over infinity. I keep ln in the denominator as is. I write 2 5x. Oh, I can put that 5 out. Doesn't matter. 5x is 1 over 5x. So it will be just this as x goes to plus. Now you look at that function, that limit, you see that, oh, this is fraction. Numerator has limit 0, denominator has limit 0, so this is 0 over 0. 0 over 0 is where you can use your friend, the tool that we call Labtube's rule. In other words, here I can replace the numerator by derivative of ln of this guy, which would be negative 2 over x squared over u. And this guy would be negative 1 over 5x squared. Can I write it on this piece here? I want to simplify that. So this and that multiplied, and this and that multiplied. I will get 10 over x squared times x squared. And in the denominator I have x plus, or maybe 1 plus 2 over x, as x goes to plus. inequality. These two cancel, and this is the limit of 10 over 1 plus 2 over x, as x goes to plus infinity. This is just quotient law. Oh, hold on. It's time for me to go. The limit is not 10. This limit is 10. The original one is e to the power 10. You should remember that step and finish that properly. Have a great day.
It's not 10.
It's not 10, it's e to the power 10. Thank you. Have a great day and see you all on Wednesday.
I just wanted to ask you, so obviously the limit of this is x goes to infinity, but the limit of this isn't 0, it's like 1 over.
No. Smaller than 1 plus. Oh. No.
Do you teach calculus 2 over the summer?
No. I teach you in summer. Well, we don't know the summer assignments.
Recommend that I